So we look at dependent events here, and dependent events are, so dependent events are events that occur when the outcomes of an event are affected by the outcomes of a previous event. And the little addendum here is that this usually happens in questions where there is no replacement. If we look at this question here, a card is chosen at random from a standard deck of 52 playing cards without replacing it. So there's the key, without replacing it. A second card is chosen. What is the probability that the first card chosen is a queen and the second card chosen is a jack? There's a couple of ways we can do this, and we usually want to try and work with our combinations. So we're looking to get a queen to begin with. And we know there's 4 queens in a pack. So we're looking for probability equaling the number of ways an event happens. Divided by the number of ways all events can happen. All events. So how many ways can we take one queen out of 4 queens? We know there's 4 queens, so it's going to be 4, choose 1. And how many ways can we take a card out of the 52 cards? Well, it's going to be 52, choose 1. So that's for the queen. And we know the second card chosen is a jack. Well, how many jacks have we got? We got 4 jacks, and we're going to choose one of them. So we can choose any one of those 4 jacks. So it's going to be 4, choose 1. Now what's the key now? The card wasn't replaced in the first place. So we don't have 52 cards anymore. We've got 51. So there's how many ways of choosing one card from 51? It's going to be 51, choose 1. So 4, choose 1 is 4, 52. And then we're going to times this by 4 over 51. So one of the keys for this is that when you're dealing with dependent events, the probability of A and B happening is equal to the probability of A, i.e. the queen being chosen, times the probability of B given that A has already happened. And that's the formula there where we multiply. And this little bit here which says, this little division sign, it's not a division sign, all it means is the probability of B given that A has happened. Okay, and all we do now is get our calculator out, and we can actually cancel this 1 over 13. I'm not sure my mental math is going to work very well here, but 4 times 1 is 4, that's an easy one. 13 times 51 is 10 times 51 is 510, 3 and 100, we're getting there, 153, so that is 663, I think, 664 actually, because 510 plus 153, which is 663, my bad. 663, I was right to begin with. So question 2 here, Mr. Peretti needs 2 students to help him with a science demonstration for his class of 18 girls and 12 boys. Randomly chooses 1 student who comes to the front of the room. He then chooses a second student from those still seated. So again, we've got this idea of not replacing because the first student doesn't go into the group of others. What's the probability both girls are chosen? So we're looking for a probability here of 2 girls. So we know the probability for that, the first girl, we've got 18 girls, so we know that it's going to be 18, choose 1. Sorry about my writing. And we've got 30 kids in the class because 12 plus 18 is 30, so that's 30, choose 1. And what we've done there is the basic rule of probability, i.e. the number of ways an event can happen divided by the number of ways all events happen. So that's the probability of the first girl. That girl now stands at the front and she doesn't take part in the next selection because now he's going to choose another girl. Now we've got 17 girls left, so we go to 17, choose 1, over. We've got 1 less kid to choose, now it's 29, we've got 29, choose 1. And therefore we get the answer of 18 over 30. 18 choose 1 is 30 times 17 choose over 29. Okay, we can cancel this out. 6 into that goes 3. 6 into that goes 5. Makes my multiplication a little easier. 3 times 17 is 51. And 5 times 29 is 145. And that's your probability of 2 girls given that event. Next question, a shipment of 20 computers, 3 are defective. So you've got 17 good ones and 3 bad ones. 3 computers are randomly selected and tested. What's the probability that all 3 are defective? The first and second ones are not replaced. So we're looking for the probability of all 3 being defective. We'll call that 3D. So now we've got 3 defective computers. How many ways can we choose one of those out? Well, that's going to be 3 choose 1. Remember, probability is the number of ways an event can happen. And we're looking for it to be defective. And we know we've got 3 defective ones, so 3 choose 1. Divided by the number of ways anything can happen. Well, we've got 20 computers. And we can do 20 choose 1. That defective computer is now put to one side. Now there are 2 computers that are defective, 19 computers altogether. So the top of the fraction will be 2 choose 1 because we know we want to choose another defective one. How many ways can we take one computer from the 19? That's the way all events can happen, 19 choose 1. And that computer is put to one side. Now we've got 18 computers left and only 1 defective. So we know that that is going to be a 1 choose 1 on top. And then we've got this 18 choose 1 on the bottom because we've only got 18 computers left. So we get 3 over 20, which is the first fraction, times 2 over 19, times 1 over 18. Now 3 times 2 is 6, and that divides into 18 3 times. So what we get on top is 1 times 1 times 1, which is 1. And 3 times 19 is 57, times 2 is 114, plus a 0 is, that is your answer. Mathematics is my business. So another question without replacement here. 4 cards chosen at random from a deck of 52 without replacement was the probability of choosing a 10, a 9, an 8, and a 7 in order. So the first of all, we're going to produce a 10. And we know we've got 4 10s, so we can choose any one of those 4 10s. So that's going to be 4 choose 1. Divided by the number of ways I could take any one card from the 52. That's 52 choose 1. Okay. Now I want to choose a 9 next. And now I've got 4 9s. And I want to choose one of them. So 4 choose 1. And I've got 51 cards left because I didn't replace the first one. So 51 choose 1. And I want to choose an 8 next. So I've got 4 8s and I want to choose one of them. So 4 choose 1. Divided by 50. Choose 1, and then I've got a 7 to choose, and I've got 4 7s, so 4 choose 1 times 49 choose 1, and this equals 4 over 52, because 4 choose 1 is 4, 52 choose 1 is 52, over 4 over 51, over 4 over 50, times 4 over 49. And that answer is 16 times 16 is 256 divided by 6,497,400. And that will reduce, and I'm going to reduce it by 8, I think. Let's do it by 4 to begin with. So 4 into 256 goes 64. And 4 into 6,497,000 times 400 is 1,624,350. And then I can reduce by 4 again. I think maybe just 2. Let's do that 2. So it's 32 over 812,175. And I think that is it because one's even and one's odd. So we'll try these 4 questions here. Question number 1 here. 20 students out of 20 students got an A, 3 students are chosen at random without replacement. What's the probability that all 3 got an A on the test? So that'd be like the defective machines and microwave question. Number 2, 3 cards are chosen at random from a deck of 52 without replacement. What's the probability of choosing an ace king? And so we've done that type of question. That should be fairly easy for you. And then moving on. Two cards chosen at random from a deck of 52 without replacement. What's the probability of choosing 2 kings? Again, that should be fairly easy. Multiple choice. And 2 cards chosen at random from a deck of 50 without replacement. What's the probability of the first card is a jack and the second card is a 10? So try those questions and see how you get on in class when we come back in class tomorrow. The key word to remember here is diagonal. Remember the word diagonal.